Hello and welcome back. In this video, we're going to look at one final tool that we need to eventually help us find the exact area under a curve. In the last video, you talked about sigma notation, saw how to work with sigma notation, how to evaluate certain sigmas. You also talked about limits at infinity. We're going to put all those ideas together and see how we can use those to look at these infinite series. I'm going to show you two examples of these. And honestly, you already know all the tools. We just need to kind of see what to do with something like this. Our first example of an infinite series is going to be the limit as n approaches infinity of the sum as I goes from 1 to n of 2i over n times 2 over n. And we're jumping right into kind of ugly looking infinite series because these are the types of series we will end up seeing that we need to be able to find the area under a curve. Please copy that down. I want to try to evaluate this thing. And I guess my first question for you is, as far as the sigma is concerned, what's the variable? Is it I or is it n? I think as far as the sigma is concerned, my variable is the I. N is just some constant that I'll deal with later on. Well, let me try to clean up the stuff inside that sigma. Why don't I actually go and multiply those two fractions together? I'm going to make this the limit as n approaches infinity of the sum as I goes from 1 to n of 4i over n squared. 4i over n squared. Now, we already said that the I is our variable. I am going to take everything else out of my sigma and leave the I inside there, because everything else, as far as the sigma is concerned, is a constant. I'm going to say this is the limit as n approaches infinity of 4 over n squared times the sum as I goes from 1 to n of I. Well, to evaluate this, we have a formula. The n plus 1 over 2 formula. Remember, those formulas don't have to be memorized, but we will use them from time to time. I don't have a number to plug in for n, but that's okay. I can just plug in my formula with the n in there. I'm going to say this is the limit as n approaches infinity of 4 over n squared, and I know that this sum is n times n plus 1 over 2. Now, this looks like those infinite limit problems that you saw in that last video. Take a moment, do some algebra to clean this up, and then see if you can take the limit as n approaches infinity and send that into Edpuzzle. This will equal the limit as n approaches infinity of 4n squared plus 4n over 2n squared. I'll do my limit of the ratio of the leading terms, and I'm going to get the limit as n approaches infinity of 4n squared over 2n squared. The n's cancel. We're going to get 2 for our final answer. I'll make the video pause if you need a moment to copy any of that down. And then we're going to take a look at one that's a little bit tougher. Okay, I'd like to take a look at the limit as n approaches infinity of the sum as I goes from 1 to n of 1 plus 2i over n squared times 2 over n. The first thing you're going to have to do is deal with this square. You need to write this thing out twice and FOIL. I'm going to make the video pause. See if you can FOIL this thing and then distribute the 2n to get something inside your sigma. So the limit as n approaches infinity of the sum as I goes from 1 to n of 1 times 1, 1 times 2i over n, 2i over n, 2i over n times 1, 4i squared over n squared, and then 2 over n. I'm going to go and combine like terms. This will give me 1 plus 4i over n plus 4i squared over n squared. And then I'll go and distribute the 2 over n to get the limit as n approaches infinity of the sum as I goes from 1 to n of 2 over n plus 8i over n squared plus 8i squared over n cubed. I'm now going to separate this into 3 different sigmas. And actually, within each sigma, I'm just going to leave the constant 2. I'll pull out the 1 over n. I'll leave the variable I, pull out the 8 over n squared, and leave in the variable I squared, leave out the 8 over n cubed. This is going to give me the limit as n approaches infinity of 1 over n times the sum as I goes from 1 to n of the constant 2 plus 8 over n squared times the sum as I goes from 1 to n of I plus 8 over n cubed times the sum as I goes from 1 to n of I squared. You have a formula for this, a formula for this, a formula for that. Take a moment and fill in those formulas, please. Limit as n approaches infinity of 1 over n times 2n plus 8 over n squared times n plus 1 over 2 plus 8 over n cubed times, n plus 1, 2n plus 1 over 6. This part is easy. This part you'll do some distributing and all that. Over here, I need you to take a moment, FOIL, distribute. Actually, why don't we just do this? This is the limit as n approaches infinity of 2n over n, which will be fine in a moment. Next, we have 8n squared plus 8n over 2n squared plus, how about I leave the 8 and the n for the moment, and I FOIL these things to get 2n squared plus 3n plus 1. I'm going to keep going with that, and I'm going to get the limit as n approaches infinity of, 2n over n plus 8n squared plus 8n over 2n squared plus 16n cubed plus 24n squared plus 8n over 6n cubed. And now I think I'm just going to cheat and go to my final answer, because I know the limit of this first part is just 2. Limit of the second thing is 4. And limit of the last thing is 16 over 6. Why don't I just call it 8/3? Add things together over here. We've got 6 plus 8/3, 12/3 plus 8/3. Oh, that's not right. Is that right? No, sorry. Yes. Wait. I don't know what I'm saying here. 6 plus 8/3 is like 18/3 plus 8/3. We're going to get 26/3 for that limit. By now, we have all the tools that we need. In the next video, we're going to look at area approximations with lots of regions. What if instead of 4 regions, we had 20 regions or 30 regions or 100 regions? And then in the video after that, we will see how to modify that a tiny bit to deal with infinitely many regions, really, 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 really narrow to get the actual area under our curve.